Good afternoon. Sarah Lewis from Lorient. We're a very proud seal manufacturer based in Devon, and we manufacture high-performance sealing systems for doors. So whether that's glazing, perimeter seals, threshold seals, air transfer grills, we're there to try and protect that door. And a very proud UK manufacturer as well. You're going to have to forgive me. I'm going to skip through some of these slides because until you actually see somebody else's presentation, you don't actually know what slides they've used. So there's going to be a little bit of repeat, but I'll try and keep it minimal. So in terms of fire door sets and fire door assemblies, ultimately, it's a fire door that's a piece of life-saving engineering designed to save lives and property. But obviously, the primary focus is to save lives. And for a door to function, that fire door could be doing a number of different things. It could be providing us with security, privacy, but when we're dealing with a fire door, it may then have to not only give us fire and smoke protection, but it might have to give us acoustic protection, as well as being able to get through these doors under document M. Now, doors naturally have gaps. That's how they function. They have perimeter gaps, they have threshold gaps. And when we're dealing with providing this tested solution for fire and smoke and sound, we're ultimately putting seals on our two long edges and the head of the door, and it's a recommendation that we seal the threshold. That will give us protection from smoke, but we know that these building regulations are advisory, they're not compulsory. However, under approved document E, when we're giving acoustic protection, if we do not seal all four sides, then we will not get that tested solution. And under document M, we've got to be able to get through these doors, and we're automatically introducing friction from the seal because it has to touch its opposing surface on the two long edges, head and the threshold. So, if this is moving on. So, approved document B. The beauty about approved document B is that it actually draws attention to the fact that that door will only work if we're looking at it as a completely compliant installed door, drawing attention to the fact that small differences might affect that rating. They say significantly. So, for example, from a seal point of view, you put the people think that seals are FD30 or FD60. They're not. It's the size that was tested that got that door through its test. So if it is a 10 mil seal, that's fine. But more commonly now, single leaf, single acting FD30s, 96 wide, 2040 tall will use a 15x4 seal. So if you fit a 10x4 seal, that door will not perform. That is not what was tested. And so Appendix C within approved document B then tells us whether we're dealing with a European tested door. It's giving us smoke capability. It's an E30 with an SA, or it's a traditional BS476 test, and therefore it's an FD30S. Safety is defined in minutes for fire doors, and the minute that we have that S or SA, we're giving that cold smoke protection, and we'll see that smoke is the killer. Now, this is where I apologize. All I can say is that the fantastic thing about these doors and their screen is that they performed exactly as they were designed and tested. Unfortunately, for this particular school in Dorset, it was their second fire. They'd actually just spent £12 million 2 years earlier doing a complete refit, but it was an electric lightning strike. And what we can see is that the fire went over the top. It couldn't get through the barrier. And as you know, this is the non-fire side. And the amazing thing about this image is that that wicker man has not caught fire. The fire's come over the top, but the intermescent glass that's been specified and used actually hasn't given any radiated heat, so they've performed amazingly. Now, unfortunately, people do die in fires, and fire and rescue not only have to put the fire out, but they have to record the statistics, and they're unacceptable. And when we look at the statistics more closely, we will actually see that the fatalities, if you haven't evacuated the building, will be down to smoke. Smoke will have knocked you out, the fire cooks you. So what we want to do is contain, I'm sounding like a drunk now, I'm on my own high. We want to contain the fire to the room of origin. We've got that combustion process happening, and we want to limit the size and spread to that compartment. Now, because the oxygen is reducing, what was originally grey smoke has risen to the ceiling, the oxygen has reduced, it's now turned black. It is highly toxic. It's traveling at phenomenal speed. It will travel through the head of the door because it's hit the ceiling and it's got to go sideways, and it will then outrun the fire. As it travels away from the fire, that smoke will still be black, it will still be highly toxic, but as it travels away from the fire, it naturally cools. It will drop and it will creep. And this is when the most vulnerable part of a fire and smoke door will be that threshold. We've said that under ADB that we only have to put seals on 2 long edges head. It's a recommendation for the threshold, but this is then when it becomes critical. So in the room of origin, that smoke is 600 degrees C. By the time it's traveled to the fire compartment, it is 25 degrees C. Highly toxic, will still burn your skin. Now, the reason for the high human casualties that we looked at earlier, if fire and rescue haven't got you out of the building safely, is because of this gas. Now, toxic smoke contains cyanide, don't get me wrong, but carbon monoxide, you cannot see it, smell it, or taste it. It's absorbed through your skin, taken by the blood straight to the brain. That's why you become giddy and disorientated. Depends how much oxygen is in the room, but you could be giddy in 20 seconds, unconscious in 60, with death then soon after. It's also the reason why when fire and rescue get you out of the building, and they're obviously totally kitted up with breathing apparatus, they carry somebody out. The first thing that the ambulance do is put an oxygen mask on your face to pump pure oxygen into your blood to try and flush this toxic gas out. So how do we know these doors are going to work? Well, we literally burn them to destruction. Now, this is what we call a parallel fire test. This isn't a pair of doors. It's got the dividing wall. I haven't got time to show you a video, but it's enough to see what you've seen earlier with other presenters, that you have got to do your time, whether that's 30, 60, 90, or 120 minutes. You can have anything from half an hour to 2, but there is nothing left at the end. It's the only way that we know the door is going to work. Now, the door would never get through that test without its intermittent seal. It's located on the 2 long edges in the head of the door. This hasn't got a clicker. So this is a plain fire seal. This is a combined fire and smoke seal. Plain fire seals, they literally will give you fire and hot smoke, room of origin. Cold smoke is the killer. That is why we have brushes or fins. That brush or fin has got to touch the opposing surface of whether it's the leaf or the frame. That location where it gets fitted is determined by the door manufacturer, but there are lots of different intermescents on the market. Now, when an intermescent seal is subjected to heat, because it's on the 2 long edges in the head of the door, it swells, it holds the door into the frame to allow the door, well, not allow, to ensure that the door will get through its test. Now, that white material is a chemical formula. It's called sodium silicate. It expands every single time at 100 degrees C, so the temperature of a kettle. If I just, as it's closer here, the most common kind of material is this kind of color. It's called graphite, but there are actually 17 to 20 different formulations. It depends who makes it as to whether it expands anything from 170 to 300 degrees C. What you cannot do in the perimeter of a door is mix and match those materials. You have to fit the seal that was tested, the size, in the location, and the manufacturer, okay? The reason you can't mix and match them, the door manufacturer, for example, SDS, may have test evidence with all of us, but we were never mixed in the perimeter, okay? And the reason for not mixing and matching, 2 things. You invalidate the test evidence of the door. In the event of loss of life or an insurance claim, door manufacturer walks away. The thing that's much more serious is that you know that sodium silicate will be expanding at 100 degrees C. We don't know when that might be. It might be 5–10 minutes before the graphite is expanding, and then you'll get the integrity failure. So, door manufacturers test their doors. This doesn't look like it wants to work. Nope. They're supposed to be swinging, and I've got nothing to touch. We all know what a single door is, and we know that a pair of doors is like that. They are single swing. But the door manufacturers test their doors, obviously, as they... Oh, thank you. I'm looking at the man at the back. So singles, pairs, single leaf, double leaf. And what we've got to make sure is that we install, if the doors haven't come into the building as a door set where everything comes together, then we've got to make sure when the contractors are bringing the components together, they fit the seal in the right location, use the right product. Everything has to be in line with that test evidence, the door. It now doesn't want to work. Now, any aperture that we put in the door will automatically weaken the core of that door, and we've got to have test evidence for it. Now, that could be something as tiny as a door viewer in a hotel bedroom door, or something as big as the letter plate. And obviously, Jeremy showed earlier, you know, the letter plate igniting and falling out. So you've got to have the test evidence for it. Now, when we're looking at this, I just really would like to point out a couple of things. My clock says 7 minutes, and you know I can talk for England. So if we're dealing with a door set, what I'm about to tell you I shouldn't have to worry about. However, if we're dealing with what we call a door assembly, where somebody goes out and buys the components and makes what we're looking at, perfectly safe, but there's a big paperwork trail to follow. And everything that we do with fire doors, we need a paperwork trail. So, vision panels. Vision panels should only be put indoors by 2 people, the original door manufacturer or a licensed converter, somebody who has been trained to do it. They will then use the right glass, they will use the right glazing seal, the right bead, and they will ensure the door has the test evidence for the amount of vision panel that you want as a client. The air transfer grill at the bottom, that is fire only. Again, the door has to have the test evidence for it. Now, that aperture has to be cut by the same 2 bodies, manufacturer, licensed converter, but that can be fitted on site. However, if you need fresh air from one side of the door to the other and you're on the escape route, you need a fire and smoke damper. And it will be an electromechanical system when it's in a door. It will be, the power will be taken to it either by a power loop or a conductor hinge, but basically it'll be hardwired into the fire alarm. If there's a power cut or there's the fire alarm going, smoke shutters will automatically come down. But the beauty is there'll be fresh air under normal circumstances, but when they're needed, they will be fail-safe. Now, face-fix closers do not need any additional intermescent, but the minute that we're mortising something in, then you may need another material called monoammonium phosphate. Haven't got time to show you, got some samples by the stand, but that basically insulates the ironmongery. So hinges, concealed door closers, and locks, sorry. But again, you've got to factor that in. Is it 1 mil material? Is it 2 mil? If we're cladding a lock and it's a 2 mil kit, that will be 4 mil that has to be either CNC routed or mitered in the door. So how do we test for smoke? Now, the fire test is obviously destruction, nothing left at the end of it. But when we test for smoke under this code of practice, it's actually a door again being built in a chamber, but it's fresh air that's being, I call it squirted at the door, but you know what I mean. We're measuring leakage. We've got seals on the 2 long edges in the head of the door, and when we test for smoke, it's something that will probably be reviewed. We gaffer tape the bottom. That's the test standard, whether it's British standard or the European standard. We have to then comply with this leakage, 3 cubic meters of smoke per meter sorry, 3 cubic, the standard's there, 3 cubic meters per meter of door per hour. Apologies. Now, when we've actually passed that test, this statement then basically tells us that we don't have to do anything, but it basically says that when that door then gets installed, that it can actually touch the floor, it's not to give any friction, and where this is impracticable, I think everybody has highlighted this, the gap should not exceed 3 mil. It's not going to function if it's touching the floor. We need a gap. If you have a fire and smoke door and you have a 3 mil gap, then that is fine. If it's bigger than that, you should be fitting something there. But from an acoustic point of view, any gap will allow smoke and sound to travel through it. Now, this just shows you what is permitted underneath the standard B in orange, and even a well-sealed door, number C, will still give you something. Smoke will travel through, for example, a keyhole. So we've got to make sure that the door has got a continuous seal around the perimeter to ensure that we comply with the smoke leakage. If you interrupt seals at the ironmongery position, so hinge one side, lock or latch on the other, smoke will travel through it. Am I in the red now?
Don't worry about it, you're fine. No, you're okay.
I've only just now looked at the screen. I am so sorry. So if we interrupt, then that will obviously allow smoke leakage. So we really need a continuous seal around the perimeter. By the way, seals are not called intermittent. They're intermescent. But you know that. So this is a great way of, again, we'll just see if it wants to work. Videos are always ticklish. It should work. Basically, a great way of sealing them is something like this called an automatic drop seal. Routed out or face fixed. Button engages on frame when the door goes in the shut position. It will drop and self-level to 13 mil. As soon as the door is opened, the button is taken away, therefore it retracts. So there's no friction. So continuous seal could be something like this one that fits in the corner of the door stop. It will be smoke and sound, but you need a plain fire seal. You could have a fin seal where it's got two fins on top of the carrier case. You can interrupt one side for hinges, other side for lock or latch. The continuous one then will catch anything that went through the interrupted one. And what we're dealing with is friction. But how do we specify the right seals? And obviously the most important thing is the first two, fire and smoke protection. Those doors have got a job to do. And we've got to be mindful of closing forces. The minute we have seals on those two long edges in the head, you can get friction. When we get friction, we get doors that are propped open if they haven't got the right ironmongery. We've got all of this stuff, it's available. And we've got to be conscious of wear and tear. Because if you've got a painted brush or you've got a fin seal that's tattered, it will not give you that smoke protection. Physical breakdown. So what we do at Lorient, very proudly, we have got third-party accreditation with those bodies. They're not scout badges. Those people come in and they regularly audit us. One of them does it 3 times a year, others do it 4 times a year. They come in regularly. They can come in unannounced, although invariably they do tell us. But, you know, you've got a factory going. You can't do something special for them. And what they do is they prove that what we're making today is exactly as we originally tested. No substitution. If we run out of brush, we can't go and buy somebody else's. If we run out of the chemical formula to make the intermescent, we can't go out and buy something else. It has to be exactly as tested. They prove the product is fit for purpose. We brand our product. It'll either be across the shoulder of the carrier case or it will be underneath the tape, but you will see it. If you're in doubt, peel it out. If it's white and it's got our brand on, it's us. But third-party accreditation means full traceability. We could have gone through all of you in the room, but ultimately it will come back to us. And I'd just like to conclude by showing you this photograph. This was way pre-Grenfell, but they had a very clear block policy. Your flat is on fire, you get out. Your flat isn't on fire, you stay behind your door. Now, they had FD60 composite doors, and there was a fire on the 11th floor. The flat was mullered. It obviously blew out the windows, and it tried to go up the cladding, but everybody was safe. They did as they were designed, but they will only work when they're properly specified and maintained and installed correctly. We have a host of stuff to be able to help you with, anything in terms of specification, in terms of site visits, CPDs, we're here. Thank you.